Okay, so right off the bat, I wanted to make a distinction between 3D printing and then this thing I'm going to talk about called additive manufacturing. So how many people, when I say 3D printing, think of this kind of thing, like a MakerBot, you're printing in plastic? I still think that even though I work for a company that's doing something very different with the technology. So what I'm talking about is additive manufacturing, where 3D printing is one step. But this is an entire manufacturing process that can actually replace manufacturing processes that we see today. So a lot of things like this table has parts that are injection molded, a lot of metal parts might be machined, but this is going to replace, this has the potential to replace all of those processes. And you can see here we get these really complex parts, like the one on the top right I'm going to talk about a little later, but that used to be 20 different parts, and now it's been consolidated down into one part, and this is part of an engine on airplanes that are currently flying in the air. And in the bottom right too, you can get these like really insane lattice structures inside of a part that there's no other process that you can do this with right now. And then also, so another thing is I kind of imagine, this is a form printer by Form Labs up in Cambridge. I imagine that this printer's like a couple $1,000s, and artists could have this in their home and be printing little figurines out to sell on Etsy. But additive manufacturing really is like on the level of Tesla's fully automated assembly lines, where like this process potentially could have like almost no human input and be creating finished products to distribute to users. So this is an overview of that, what that additive manufacturing lifestyle or life cycle looks like. So we're starting as early as the part design. So using this process of 3D printing, but in this like kind of high-tech level, actually changes the way that we design parts from the start. The production itself, so that step is where the 3D printing comes in. It changes how we're producing parts. Logistically, like where the warehouses are located, how much warehouses, how many people we need for assembly, like that is all being changed by this process. And then finally the use of the product in the end. So first up, so I'm a mechanical engineer. I know we're not super represented at this conference, but if there are more of me, you might recognize like some of the pictures on the bottom left are like constraints of current manufacturing processes. But what's happening when we're implementing 3D printing on this high level is that, one, you can consolidate down to fewer parts. So in the top right, like I said earlier, this little engine part used to be 20 different parts. Someone had to assemble that. They were using fasteners like screws and bolts to assemble that together. And now they can print this super complex geometry in one single part. And this is they did a cutout so you can see inside. But if you can imagine, like, there's no other way that you can create this part unless you were able to 3D print it. And then the bottom right, I like this image because it's just super tangible that the top part was machined. So they started with a block of material and they removed the material they needed to create this shape, and they were kind of limited by by this current process, how they were doing that. But you can see the limitations when you look at the 3D printed part below. That part is totally reduced to just what you needed to have the strength and the geometry of the part. So you're able to cut out all this material. The fact that you're building from the ground up in 3D printing means that you only use the material that you needed for the strength constraints of this part, or the necessities of this part. So you can see there's a huge savings in the amount of material that was being used. And one other thing I'll touch on a bit later in the use life is when you're reducing the weight and maintaining the strength of a part, that's going to be a huge difference in like the amount of fuel you need if that part is part of an airplane, for example. So then the production itself. If people aren't familiar with machining, or even if you're not, if you know like a MacBook, that starts as a block of aluminum, and then you're taking away material in order to reveal what that housing is going to look like. So all of that aluminum that you machine off, it's often really hard to reuse that, so sometimes it's just being thrown away, sometimes it is being recycled, but that material is not going to be the same quality material as that original piece of material was, so aluminum from a MacBook Pro can't be used to make another MacBook Pro. But what's really cool with 3D printing is that you're only depositing or using the material that you need. So if there is other material in the process, it can just be wiped away and reused, or potentially you're not using any material except for what you need. So that's one of the huge, like right off the bat, a super sustainable option with this process. Also, like I love these images on the right. These, the top image actually exists. That's a 3D printed car. So they 3D print their frame. They're reducing tons of parts. You can see it looks kind of weird, and that's probably because maybe like software engineers designed a way to simplify down what they needed for that car frame just to what they needed for the strength and the structure of that. So they were able to probably reduce they were able to reduce a ton of the parts and definitely the amount of material needed. And then you can see what they're assembling in is just things like some of the wiring and electronics, the wheels, the place where the person's sitting, the steering wheel. And then they also 3D printed the outer housing of the car and just can kind of pop that on. So one thing that's really cool with manufacturing this way is that you're also reducing the amount of personnel that you need to manufacture your parts. I know that is up for debate whether that's really great. It feels like a lot of jobs might be phased out with all the technology that's coming out. But in terms of sustainability, that means that there are less warehouses that you need with the personnel in them assembling these parts. And where that'll come in is that also if you need less warehouses and smaller warehouses, maybe you can start to move those closer to the places where the parts are going to be used. So reducing a little bit of the transportation of these parts. And then the bike I thought was a super tangible example because like I don't have a car. I think a lot of people here don't. So a bike as well, like this looks like about the same material I would say as a normal bike frame would use, but it's all printed in one part instead of being welded together into a frame. So I touched on this a little bit on the last slide, but logistically, how many people know about like Amazon, how they do predictive analytics and like data analytics to figure out where their products are going to be needed before it actually happens? So what they do is they have big warehouses where they're stocking all the products, but then they try to predict where they're going to be needed and then ship them to smaller local warehouses so that you can get them the same day or the next day, as opposed to waiting for them to come from those really large warehouses. So this is taking that a step further, that instead of a physical inventory, you can have a digital inventory. So you don't even need that big warehouse. You just have a local warehouse. Someone goes in, loads in the file of the product that's been ordered, it prints, and then it ships directly to you. So if you've heard of last mile delivery, the like really long-term end goal for this is maybe that's the only delivery that we have. It's just that last mile. Everything else could be cut out. That obviously is very far in the future, or not, maybe not so far, but there are printers that are printing multiple materials right now, but right now, for example, what I'm working in is just printing metal. And most products that you see around you, like, this has more than just one material. It's plastics, it's circuit boards, it's metals. So there would be there's a bit more research and development to be done there. But yeah, there could be a huge savings in terms of the energy that we expend for transportation. And then finally, in the use and like life cycle of a part. So one that's really fun is down in the lower right. That's actually a divider for an airplane. So I don't know if it's a little hard to visualize when you first see it, but if you're like walking down the body of an airplane and they have a divider between like first class and regular class, like that's one of those dividers. So that gives you a bit of an idea of the scale of what we're printing right now. And for that part, that usually would be made out of just sheets of metal. But instead, again, they use some kind of like a software to figure out, like, break this part down and suggest the structural supports that you need to create this divider. And there was a lot of, I'm sure a lot of research that went into that to figuring out how to make sure that it would be strong enough to withstand the vibrations and the pressure changes on an airplane. But they were able to simplify it down to this, and this is a huge weight reduction in that part. So if you imagine on an airplane, if you were able to reduce the weight of all the parts on the plane, all of a sudden you're using a lot less fuel to fly that plane, or you could load a lot more into that plane. So maybe you can start to consolidate the amount of trips that airplanes are flying every day. Upper right is a little bit more of an abstract concept, but this is a heat sink. So in data centers, when you have, this is a little bit different for me to talk about, but you'd have a ton of, hard drives working, there's a lot of heat being generated. So I think they say about 30 or more than 30% of the energy expended at a data center is just on cooling all the systems in there. So parts like this would they draw heat away, and then maybe that heat would be fanned away from the parts that are outputting that heat. But this part is 14% more efficient than most heat sinks that are out there. And the reason they were able to increase that efficiency is because they're using geometries that aren't able to be created by any other manufacturing process. So actually, I'm just going to go back because I wish I put that on the slide. But things like this kind of lower right lattice structure, you can create these really complex geometries that maybe you could get in there with tiny tools and weld together tons of little rods of metal to create this geometry. But with 3D printing, it becomes a really cheap and easy thing that you can create. Back to the slide. And then finally is the actual use life, or the lifetime of a product. So if you're reducing the amount of places where the product is assembled, like those joints, that's reducing the amount of places where it could fail. So potentially, right now, I think airplanes are usually in the air for 20 to 25 years. What if we could move that up to 30 to 35 years? We're making less parts. And then also, if things aren't breaking, there's less need to replace parts. But if they do break, what if you could just create a replacement part right on, really close to your house and have that shipped, that last mile to you? Maybe then you're going to use that part or that product for a lot longer as opposed to just completely replacing it. And actually, one other really fun thing is, say you have a car from the 60s. Right now, it'd be really hard to get parts made for that car. If something breaks, it's kind of you have to figure out how to make that yourself, or maybe you just have to trash the car. But what if all those parts were now just in this digital inventory? Now that car is never obsolete, you can continually replace parts for it. So that would go for any generation of a product. Yeah, so my name is Tara Ptolemy-Ebsworth. I work for Hollow, and we're looking at both creating a 3D printer for this process, but then also looking at the entire process. So feel free to talk to me after this if you're interested. I didn't touch too much on how software plays into this, but our teams are materials, engineering, mechanical, and software. So software is a huge component. Thanks.